Welcome, curious minds. Today, we're embarking on a deep dive into generative AI, a topic not just reshaping industries, but fundamentally changing how we interact with technology, really.
Yeah, definitely.
Our mission today, to cut through the noise, pull out the most important insights, and hopefully give you those aha moments. Give you that edge for a big meeting, or just satisfy that curiosity.
Exactly. We've basically synthesized a whole stack of really insightful sources, everything from the history of AI right through to how Google Cloud is enabling enterprises today.
Hmm.
So we're ready to explore what generative AI truly is, how it works, its applications, and crucially, how businesses can harness this responsibly. Think of this as your essential shortcut, basically, to being well-informed.
Okay, let's unpack this. So our journey today,
Mm-hmm.
we'll cover the basics, AI, machine learning, then dive into generative AI itself, how the models work,
Right.
and then how Google Cloud puts these tools in your hands, always keeping an eye on responsible AI.
Yeah,
You should walk away with a much clearer picture.
sounds like a plan.
So let's set the stage. Our sources mention AI is in its third golden phase. Can you kind of paint a picture of that journey for us? How did we get here?
Absolutely. It's been quite a ride, actually. The first phase, way back, 60s, 70s, that saw early symbolic reasoning, some successes, but limitations too.
Okay.
Then the second phase, let's say roughly 2000 to the 2020s, brought major breakthroughs. We saw new machine learning, deep learning algorithms
All right, right.
fueled by, well, massive data sets and much more powerful computing hardware. Things like GPU's graphics processing units and Google's TPU's tensor processing units, these were game changers for training complex models.
Okay, so more data, more power.
Exactly. But what really accelerates us into this third phase, the current one, is generative AI. It's a leap from just analyzing or predicting to actively creating.
That distinction, predicting versus creating, that feels really important. Before we dive deeper into generative, maybe just quickly frame AI again. The dictionary talks about tasks needing human intelligence.
Right. At its core, AI is about building machines that can simulate human-like intelligence for usually specific tasks. Think playing chess, recognizing speech, maybe making a purchase recommendation.
So specialized tasks.
Yes, and it's crucial to understand we're largely talking about narrow AI or weak AI. It's designed for one specific thing. Strong AI or general AI, machine intelligence equaling human intelligence across all tasks, that's still very much theoretical. Way off, probably.
Got it. So our focus is on these powerful but specialized systems.
Precisely.
So AI is the big umbrella. Where does machine learning, ML, fit into this picture?
Okay, so ML is a subset of AI. The key idea is that machines learn from data, from examples, instead of being explicitly programmed with every single rule.
Oh, okay. Learning from data, not rules.
Exactly. Think about predicting a house price. Instead of a programmer writing thousands of if-then rules about square footage, location, age, an ML model learns the patterns directly from millions of past sales records. This shift from rules to data is profound. It lets systems adapt and improve without someone having to constantly reprogram them. It's how your phone recognizes your handwriting, right?
Right.
Not because someone programmed every possible squiggle,
Right, yeah.
but because it learned from seeing countless examples.
Okay, that makes sense. And that learning from data, that brings us squarely to generative AI, the star of this third phase.
Yeah.
What's its unique contribution here?
Right. So unlike traditional ML, which might predict that house price or classify an email as spam, predictive tasks, generative AI's purpose is to produce something new.
Create content.
Yes, it's the AI that writes original text, generates completely novel images, composes music, or even writes functional code snippets. It's not just recognizing patterns, it's extending them, synthesizing them to create entirely new stuff.
This sounds incredibly powerful, almost magical sometimes. But our sources do highlight that building these AI solutions, well, it hasn't been easy. They mention challenges like skills scarcity and data complexity.
Oh, absolutely. That's very real. First, the talent pool for really specialized AI and ML skills,
Yep.
it's still growing. It can be genuinely tough for organizations to find the right experts.
Right.
And beyond that, just acquiring, cleaning, labeling, managing the absolutely massive data sets these models need, that's an enormous undertaking in itself.
I can imagine.
Then you need the sheer computational power to actually train these huge models. All of this adds significant complexity, and that's even before you get to deploying and maintaining the model in the real world, making sure it keeps working well.
So Okay, how do we actually build these systems then? The sources lay out a pretty clear life cycle, right?
Yes, the machine learning lifecycle, it basically guides projects from just raw data all the way to a functioning model. It typically involves 5 key steps, and they're often iterative. You kind of circle back.
Okay, what are they?
First, data ingestion. Just gathering the raw data from wherever it lives could be streaming user activity, transaction logs, sensor data, you name it.
Step one, get the data.
Step 2, data preparation. Cleaning it up, formatting it. This is often, honestly, the most time-consuming part. Removing duplicates, handling missing values, maybe transforming formats, and crucially, for many models, labeling the data, giving it meaning.
Labeling, like
Yeah.
telling it this is a cat, this is a dog.
Exactly. Or this review is positive, this one's negative. Step 3 is model training. This is where you actually teach the model using that prepared data, feeding it the labeled images, for instance.
The learning part.
Right. Then step 4, model deployment. Making the trained model available for people or systems to use. Maybe integrating a new AI feature into your app or launching that chatbot on your website.
Putting it to work.
And finally, step 5, model management. This is crucial and ongoing. You have to continuously monitor how the model's performing out there in the real world, retrain it with new data periodically, make sure its accuracy doesn't drift or degrade over time. It's definitely not a one-and-done thing.
Okay, that cycle makes sense. Ingestion, preparation, training, deployment, management, and you mentioned data preparation being key. One source even highlights data is the key. What kinds of data are we actually talking about, and why does the type matter so much for AI?
Good question. Data primarily falls into 2 main categories based on its structure. First, you have structured data. This is highly organized, easily searchable stuff. Think of information neatly arranged in a database table, clear columns for customer IDs, names, addresses, or an Excel spreadsheet tracking orders.
Neat and tidy.
Exactly. Then you have unstructured data. This is the free-form stuff, lacks a predefined format. Think customer emails, social media posts, audio recordings from call centers, YouTube videos, scanned documents. It's messy, but often holds incredibly valuable insights.
I guess they need different handling.
Totally different. Extracting meaning and training models on unstructured data requires very different techniques, often more complex ones, than working with structured data.
Okay, and how do we prepare that data for the model to actually learn from? You mentioned labeling. Does it always need labels?
That brings us to how the data is tagged, or if it's tagged. So labeled data is data that's been tagged with specific meaning. Like we said, images tagged cat or dog, reviews labeled positive or negative.
Right.
This is absolutely essential for supervised learning. That's where the model learns by example, and it's supervised by these labels telling it the right answer. Generally, more high-quality labels mean better model performance, but creating those labels can be really expensive and time-consuming.
Okay, so labeled data for supervised learning. What about data without labels?
That's unlabeled data, just raw data, no predefined tags. This is used in unsupervised learning. Here, the models have to discover patterns entirely on their own without any guidance or correct answers provided.
Like finding hidden groups.
Exactly. Things like clustering similar documents together or identifying unusual anomalous patterns in network traffic that might signal an issue. It finds structure where we haven't explicitly defined it.
So we have supervised learning with labels, unsupervised learning without labels. And then there's a third major type too, isn't there?
There is. That's reinforcement learning. The analogy often used is teaching a child to walk, or maybe teaching a robot arm to pick up an object.
Right.
Instead of programming every single muscle movement or joint angle, you give the agent, the robot, or the AI a goal, and then you provide feedback. A reward when it does something right, gets closer to the goal, and maybe a penalty when it fails or does something wrong.
So it learns by trial and error.
Precisely. It learns through trial and error, experimenting with different actions to maximize its cumulative rewards within a dynamic environment. This learn by doing and getting feedback approach is perfect for complex control tasks. Think game playing AI, mastering chess or Go, or optimizing complex industrial processes in real time.
Okay, supervised, unsupervised, reinforcement. Got it. Now here's where it gets really interesting, connecting back to generative AI. What is it that actually powers these systems? What allows them to create this new, often quite astonishing content?
Right, that's where foundation models come in. These are, well, they're enormous AI models. We're talking models trained on absolutely staggering amounts of diverse data text from the web, books, articles, vast amounts of code, images, sometimes audio and video too, across many different domains.
Huge, diverse data sets.
Huge, and that's key. Unlike traditional ML models, which are often narrow, trained for just one specific task, like a spam detector that only detects spam and can't write a marketing email. Foundation models are incredibly adaptable.
Adaptable? How so?
Because they've learned such broad patterns from that massive, diverse data, they can be fine-tuned or prompted to perform a wide variety of tasks without needing to be retrained from scratch each time. They form the foundation, hence the name, for countless different generative AI applications. Their scale and the breadth of their training allow them to understand context, generate creative text, synthesize images, write code in ways we just haven't seen before.
Okay. Foundation models. Big, adaptable, powerful. Google obviously has some major players here. Gemini comes to mind immediately. What makes Gemini stand out?
Gemini is a great example. It's Google's umbrella brand for its generative AI ecosystem, and it's a prime example of a multimodal foundation model.
Multimodal. Meaning?
Meaning it can seamlessly understand and operate across different types of information, text, code, images, audio, and video, all at the same time within the same model.
Wow, okay, so it's not just text in, text out.
Exactly. This multimodality is what allows Gemini to do really complex things, like answer questions about charts in a document, generate Python code based on a spoken description, or even create new images based on a combination of text and image prompts. It's closer to how humans process information from multiple senses.
That sounds incredibly versatile.
It is, and Gemini is also available in different sizes or versions. There's Gemini Pro, which is sort of the versatile workhorse. There's Gemini Flash, optimized for speed and efficiency. And then there's Gemini Nano.
Nano. For smaller things.
Yeah, Nano is designed to be really compact and efficient, specifically for running directly on devices, like your Pixel phone. This enables private, offline AI capabilities, think summarizing recordings or suggesting replies without needing to send data to the cloud.
That on-device capability feels important for privacy and speed. Okay, so Gemini is key, but it isn't the only innovation in Google's foundation model lineup, right?
Absolutely not. Google has a whole portfolio. We also have Gemma. This is a family of lightweight but still state-of-the-art open models.
Open models.
Meaning their architecture and sometimes weights are released publicly. They're built using the same research and technology behind Gemini, but being open allows developers and researchers worldwide to build upon them, customize them, and innovate faster. There are specialized versions too, like Code Gemma for programming tasks.
Okay, Gemma for open innovation. What else?
Then there's Imagen. This is Google's advanced text-to-image model. What's fascinating here is how it works using a technique called diffusion. It essentially starts with random noise and intelligently refines it step by step based on your text prompt to synthesize these incredibly high-fidelity, often photorealistic images, turning ideas into visuals.
From noise to image, that's cool.
It is. And most recently, VO. This is Google's cutting-edge video generation model. It can take text prompts, images, or even existing video clip and generate high-definition, coherent video sequences. This could really revolutionize content creation, animation, storytelling.
Wow, video generation too. So
Yeah.
Gemini, Gemma, Imagen, VO. It's a powerful suite. It truly sounds like these models are capable of incredibly versatile and, well, intelligent creative tasks. But while these foundation models are astonishing, you hear about quirks, right? They're not perfect. What are some of the critical limitations we absolutely need to be aware of when we're using them?
That's a really important point. It's crucial to understand their boundaries. They're tools, powerful ones, but still tools with limitations. Some common ones include, first, data dependency. Their output quality is fundamentally tied to the data they were trained on. If you train a legal AI on outdated laws, guess what? It's going to give you outdated legal advice. Garbage in, potentially garbage out, or at least outdated information out.
Okay, makes sense. What else?
Knowledge cutoff. Models generally only know things up to the point their training data ended. They don't typically have real-time access to breaking news or events that happen after their training finished.
So they can be out of date.
Yes. Then there's hallucinations. This is a big one, and a term you hear a lot. It's when the AI generates outputs that sound completely plausible, confident, well-written, but are factually incorrect or just plain made up.
Like confidently wrong.
Exactly. A classic example is an AI generating an academic citation, complete with author, title, journal, but the paper it cites simply doesn't exist. It just fabricated it, but made it look real.
Ooh, that's tricky.
Very. Then there's bias. AI models can unintentionally learn and even amplify societal biases present in their training data. If historical hiring data shows bias against a certain group, a model trained on that data might replicate or worsen that bias in its own recommendations.
So it reflects the biases in the data.
Unfortunately, yes. And related to that is fairness. Models might simply perform less accurately or reliably for underrepresented groups in the training data. Think of a facial recognition system trained mostly on lighter skin tones, having lower accuracy for darker skin tones. These aren't necessarily intentional choices by developers, but consequences of the data reflecting real-world disparities.
Right, inherent challenges.
And finally, edge cases. Rare, unusual, or unexpected situations or inputs can sometimes expose weaknesses in a model, leading to unpredictable or poor performance. They're trained on common patterns, so uncommon ones can trip them up.
Okay, that's a sobering list. Data dependency, knowledge cutoff, hallucinations, bias, fairness issues, edge cases. So what does this all mean for us using these tools? Given these limitations, how do we get the best, most reliable, most trustworthy output from them?
Great question. This leads us directly into key strategies for mitigating these issues. One really critical approach is grounding.
Grounding, like connecting it to the ground.
Sort of. It means connecting the AI's output to trusted, verifiable sources of information. Often this means connecting it to your own private data, things like your company's internal knowledge bases, product documentation, support articles, recent reports.
Link it to known, good info.
Precisely. This dramatically reduces the chance of hallucinations because the AI isn't just relying on its general, sometimes flawed internal knowledge. It's forced to base its answers on specific, verified facts you provide. This builds trust significantly.
How does that work technically?
A really powerful technique for grounding is called retrieval augmented generation, or RAID. You'll hear this acronym a lot. Here's how it works, roughly. When you ask the AI a question, the system first retrieves relevant chunks of information from that external trusted knowledge base, your documents, database, etc. Then it takes that retrieved information and augments the original prompt, basically. It adds the relevant facts to the question it sends to the core AI model.
So it gives the AI the relevant context, right, with the question.
Exactly. And then the AI model generates its response, but now it's grounded in those specific retrieved facts. It's how a customer service chatbot can pull precise, up-to-the-minute details from your internal IT support database to answer an employee's query accurately, rather than guessing or hallucinating.
That makes so much sense.
So,
Okay, grounding and RAG are key for accuracy. Another big technique I keep hearing about is prompt engineering. What exactly is that, and how does it help us?
prompt engineering. It's really becoming both an art and a science. It's all about crafting the instructions, the prompt you give to the generative AI model to get it to produce exactly what you want. Think of it as learning how to ask the right question in the right way.
Better instructions, better results.
Fundamentally, yes. Better prompts lead to significantly better, more relevant, more controlled outcomes. And it's a skill anyone using these tools can develop. There are several common techniques.
Like what?
Well, the simplest is zero-shot prompting. You just ask a direct question without providing any examples, like, summarize this article, or which of these is a programming language, A, Docker, B, Python.
Straightforward.
Then there's few-shot prompting, or one-shot if you give just one example. Here, you provide one or a few examples of the kind of output you want right there in the prompt before you ask your actual question.
Show, don't just tell.
Exactly. This is incredibly effective for guiding the AI on specific formats, styles, or types of reasoning. Like if you want it to generate JSON objects, you show it an example JSON first.
Ah, clever.
Then, for more complex tasks, we get into things like chain-of-thought prompting or COTI. Here, you explicitly ask the model to think step by step or show its reasoning before giving the final answer.
Make it explain itself.
Pretty much. This forces the model to break down the problem, which drastically improves accuracy for tasks involving logic, math, or complex reasoning. You see the intermediate steps.
This sounds really useful for checking its work.
It is. And then there's even more advanced stuff like React prompting. React stands for reason and act. It allows the model to sort of cycle between thinking about what it needs to do next, reason, and then taking an action, like using an external tool act.
External tools, like searching the web.
Exactly. So the model might reason, I need the current stock price for company X. Then it takes the action. Use search tool to find stock price for X. It gets the result, reasons about how to incorporate that into the answer, and then generates the final response. It mimics how humans often iteratively gather information and think.
Wow, okay. Zero shot, Few shot, chain of thought, react.
Yeah,
Lots of ways to guide the AI through the prompt itself.
definitely. And mastering these can make a huge difference in the quality and reliability of the output you get.
Now, beyond the words we actually used in the prompt, can we also sort of fine-tune the AI's personality or the style of its response? Like make it more creative or more factual?
Absolutely. That's where sampling parameters come in. These are settings you can often adjust when interacting with a model, and they influence how the model chooses the next word or token when generating its response.
Okay, what are the key parameters?
Two big ones are temperature and top P. Temperature controls the randomness, or you could say the creativity of the output.
Temperature for creativity.
Yeah, a low temperature, say close to zero, like 0.1 or 0.2, makes the model very deterministic, very focused. It will pick the most statistically likely next word. This is great for factual answers, summarization, tasks where you want precision. What is 2 plus 2? You want a low temperature for that.
Right, just the facts.
But a high temperature, say 0.8 or 1.0, makes the model take more risks. It increases the chances of selecting less probable words, leading to more surprising, creative, sometimes unexpected outputs. This is ideal for brainstorming, writing poetry, generating different story ideas.
So, low temp for factual, high temp for creative. What about top P?
Top P, also called nucleus sampling, works a bit differently, but has a similar goal of controlling randomness. Instead of considering all possible next words, Top P tells the model to only consider the most probable words whose cumulative probability adds up to a certain threshold, the p-value.
Okay, so that helps.
A low top p-value, like more 0.1, means the model only considers a very small set of the most likely next words, leading to safe, predictable, often repetitive text. A high top p-value, like 0.9 or 0.95, allows the model to consider a much wider range of possibilities, including less common words, which can lead to more interesting and diverse outputs, while still avoiding the completely nonsensical words that a very high temperature might sometimes produce.
So it's another way to balance predictability and creativity.
Exactly. Often you'll use temperature and top P together to fine-tune the output style. And of course, there's usually an output token limit setting, which simply lets you specify roughly how long you want the response to be, measured in tokens, where maybe 100 tokens is about 70-80 words, give or take. Mastering these parameters really turns interacting with AI into more of an art.
Temperature, top P, token limits.
Bad pick.
Got it. This is all incredibly powerful stuff. So switching gears slightly, how does Google Cloud actually bring these cutting-edge AI capabilities, the foundation models, the tools, the techniques, to businesses and individuals? How do they make it, enterprise ready?
That's a key focus for Google. They've publicly stated they've been AI first since way back in 2016. AI isn't just a product for them. It drives core services like search, translate, photos.
Right, it's embedded everywhere.
Exactly. And Google Cloud's goal is to make that same deep AI innovation accessible to all organizations so they don't have to reinvent the wheel or build everything entirely from scratch, which is incredibly hard. The platform is explicitly designed to be enterprise ready.
What does enterprise ready mean in this context?
It means focusing on things critical for businesses, being responsible, secure, private, reliable, and highly scalable. It also means leveraging Google's own advanced AI-optimized infrastructure, things like their custom TPUs, high-end GPUs, and even specialized hypercomputers designed for training these massive foundation models efficiently. They're democratizing access to that cutting-edge AI power.
Okay, so for a business looking to actually harness this power,
Yeah.
what are the key platforms and services within Google Cloud that they should know about? Where do they start?
Google Cloud offers a really comprehensive suite, kind of layered for different needs. At the core, for managing the entire machine learning lifecycle, both traditional ML and the newer generative AI, there's Vertex AI.
Vertex AI, that sounds central.
It really is. It's Google Cloud's unified AI platform. It helps you build, deploy, manage, and monitor your models. Within Vertex AI, there's something called Model Garden. Think of it like a curated library.
A garden of models.
Exactly. It gives you access to hundreds of pre-trained models, not just Google's own like Gemini and Imagen, but also models from partners and popular open source models. It lets you find the right starting point quickly, whether you want to use a model as is or fine-tune it on your own data.
Okay, so Vertex AI for the life cycle, Model Garden for the models. What else?
For actually building and experimenting, particularly with generative AI, there's Vertex AI Studio. This provides a user-friendly interface and tools specifically for working with foundation models, testing prompts, adjusting parameters, fine-tuning, and deploying them. There's also Google AI Studio for more rapid prototyping, but Vertex AI Studio is geared towards those enterprise-ready features like enhanced security and MLOps integration.
Studio for building and tuning. Makes sense.
Then for creating those custom AI-powered search experiences we talked about using your own company data, there's Vertex AI Search. This is a powerful tool for building internal knowledge search or customer-facing semantic search, and it's a key enabler for those RAG applications we discussed earlier, grounding responses in your data.
All right, the RE enabler.
And for teams that might not have deep ML expertise but still want to build custom models, there's AutoML. It automates large parts of the model building process. You basically provide your labeled data, and AutoML handles much of the complex model selection and tuning for you, producing high-quality custom models for tasks like image classification or forecasting.
AutoML for easier custom models.
Yes. And then specifically for creating conversational AI applications, chatbots, virtual assistants, there's Vertex AI Agent Builder. This platform simplifies building sophisticated custom generative AI agents for things like advanced customer service, internal help desks, or creating specialized knowledge experts based on your company's information.
Agent builder for conversational AI.
Right. And we shouldn't forget about empowering employees directly. There's Gemini for Google Workspace. This embeds AI assistants right into the tools many people use every day. Gmail, Docs, Sheets, Meet. It helps with drafting emails, summarizing long documents, generating formulas and spreadsheets, brainstorming ideas, making everyday tasks faster and easier.
AI in your daily workflow.
Exactly. And related to that, there's Google Agent Space, which acts as a kind of enterprise AI hub. It allows companies to create and deploy custom AI agents that can securely access and act upon internal company knowledge stored in various places like Google Drive, SharePoint, databases, etc., streamlining complex workflows.
Agent space for internal knowledge access. Okay, that's a lot of tools. What about running AI? Not in the cloud, but closer to where the data is actually generated, on devices.
Ah, yes, edge computing. That's crucial for situations needing real-time decisions, low latency, or enhanced privacy. Edge computing brings AI processing to local devices or nearby edge servers.
And Google has solutions there too.
Definitely. We mentioned Gemini Nano earlier. That's Google's most compact and efficient AI model, specifically built for running on edge devices. It enables those private, fast, and often offline AI functionalities we see emerging on phones, like the call notes or recorder summaries on Pixel phones, where the processing happens right there on the device.
Nano for the edge.
Got it. And for customer engagement specifically, it sounds like Google has pulled together a pretty comprehensive offering there.
They have. Google's customer engagement suite really leverages AI across the board. It includes conversational agents, those AI virtual agents providing 24/7 support via text and voice, handling common queries automatically.
The chatbots.
Right, but increasingly sophisticated ones. Then there's Agent Assist. This doesn't replace human agents, but helps them in real time. While they're talking to a customer, AI can suggest relevant responses, pull up necessary documents or knowledge articles automatically, making the human agent faster and more effective.
AI supporting the humans.
Exactly. And conversational insights. This uses ML to analyze customer interactions calls, chats to automatically detect things like customer sentiment, common complaints, emerging trends, or even identify areas where agents might need more training.
Learning from the conversations. Yes. And all of this is typically built on their contact center as a service, CCOAS platform, which is a modern cloud-native foundation for managing all customer interactions across different channels, voice, chat, email, social media. Imagine a retail brand offering instant 24/7 product support via an AI agent, or a bank analyzing call patterns to proactively improve agent training and reduce customer frustration. It's about enhancing that whole customer experience.
Okay, Vertex AI, Search, Agent Builder, Gemini and Workspace, Nano for Edge, the customer engagement suite. It's clearly a very broad and deep ecosystem. This all sounds incredibly strategic. So for organizations looking at all this potential, wanting to leverage generative AI, where do they even begin? What's the strategic roadmap look like?
That's the million-dollar question, isn't it? The sources suggest a pretty clear strategic path is needed. It's not just about plugging in tech, it's about thoughtful integration. First, you need to establish a clear vision for your Gen AI initiatives. What business goals are you trying to achieve? How does AI help get you there? It needs to be aligned with the overall business strategy.
Start with the why.
Absolutely. Then, Prioritize high-impact use cases. Don't try to boil the ocean. Focus on opportunities where AI can deliver tangible, measurable benefits relatively quickly. Look for the quick wins that also build momentum and learning.
Focus on value.
Right. Then, you obviously need to invest in capabilities. This means not just the technology, the cloud platform, the tools, but also building the right infrastructure and, crucially, developing the necessary skills within your teams or partnering to get them.
Tech and people.
Yes. And related to people, you need to drive organizational change. This often requires breaking down silos. You need cross-functional collaboration, business leaders defining the goals, AI practitioners building the solutions, developers integrating them. It needs active enablement and change management.
Get everyone on board.
And finally, maybe most importantly, champion responsible AI right from the very beginning. Embed principles of fairness, transparency, security, and accountability into your AI projects from day one. Don't treat it as an afterthought.
Responsible AI from the start. Okay, that makes sense. Vision, priority, capabilities, change, responsibility. It sounds like you need both a top-down vision and some bottom-up experimentation.
Precisely. That hybrid approach seems to work best. Leadership needs to define the strategic direction, set the guardrails, allocate resources, but the actual innovation, the practical applications, often come from individual teams experimenting, finding what works in their specific context, and providing that crucial feedback loop.
Top-down meets bottom-up.
Exactly. This ensures you get both enterprise-wide alignment and real-world relevance. It's also really important strategically to differentiate how you're using Gen AI. Are you using it for augmentation supporting complex human thinking, like helping a strategist analyze market trends or a researcher synthesize findings? Or are you using it for automation handling repetitive, predictable tasks like data entry or basic report generation?
Augmentation versus automation.
Right. Both are valuable, but the truly transformative results often come from that powerful human-AI collaboration, the augmentation side, where AI enhances human capabilities rather than just replacing tasks.
That brings us right back to that critical point you just mentioned, responsible AI. We've touched on it, but what does it really entail in practice? What are the key components?
Responsible AI is fundamental. It's about developing and deploying AI systems ethically, proactively ensuring they avoid causing intentional or unintentional harm. It means making sure systems are safe, fair, transparent, and accountable.
Okay, so what are the pillars?
Well, security is foundational. You have to protect the data and the models throughout the entire lifecycle, from ingestion through training to deployment and use. Google talks about their Secure AI Framework, or SAIF, which provides guidance, leveraging core security tools like Identity and Access Management, IAM, and Security Command Center to manage AI-specific risks.
Security first.
Definitely. Then, transparency and explainability. Users and often regulators need to understand at some level how AI systems make decisions. Why was this loan application denied? How did the AI reach this recommendation? Techniques for model explainability are crucial here.
Understanding the why.
Yes. Privacy is another pillar. Safeguarding sensitive user data is paramount. This involves techniques like data anonymization, pseudonymization, differential privacy, and ensuring compliance with regulations like GDPR or CCPA.
Protecting user data.
Crucially, addressing data quality, bias, and fairness. We talked about how poor, incomplete, or biased training data can lead to skewed, unfair, or even harmful outcomes. This is a huge focus area. It requires actively auditing your data for potential biases, working to balance data sets using fairness assessment tools, and being vigilant about potential discriminatory impacts.
Fighting bias in the data.
It's an ongoing effort. Then there's accountability. Ultimately, someone or some entity must be responsible for the AI's decisions and actions. This raises complex questions about governance, oversight, and liability, especially as AI systems become more autonomous.
Who is responsible?
A critical question.
Right.
And finally, a key mechanism for ensuring responsibility is incorporating humans in the loop, often abbreviated as HITL.
Humans in the loop. HITL.
Right. This means designing systems where human judgment and oversight are integrated at key points, maybe before the AI acts, during its process for review, or afterwards for auditing and correction. This is absolutely essential for critical or sensitive applications. Think content moderation, medical diagnosis assistance, financial decision-making. It ensures that human values, context, and ethical considerations remain central, especially where the stakes are high.
So keeping humans involved, especially for important stuff. Okay. Security, transparency, privacy, fairness, accountability, and humans in the loop. That's a solid framework for responsible AI. Wow, what an incredible deep dive. We have really covered a lot of ground. We journeyed from the basic definition of AI through its historical phases. We explored the nuts and bolts of machine learning life cycles, data types.
Yeah, supervised, unsupervised, reinforcement.
Exactly. Then we unveiled the power of Google's foundation models, Gemini, Imagen, Gemma, VO. We learned about their limitations, but also how to overcome them with things like prompt engineering, RAG, grounding.
And adjusting those sampling parameters like temperature and top P.
Right. And we saw how Google Cloud is packaging all this up for enterprise use with Vertex AI, Agent Builder, the search tools, making it accessible.
And importantly, we really underscored that paramount importance of responsible AI, building systems that aren't just powerful, but are also designed to be secure, fair, transparent, and accountable from the outset.
Yeah.
It's really about empowering organizations, empowering individuals to leverage AI's incredible potential while making absolutely sure that human oversight and ethical considerations remain central to how it's developed and applied.
So, wrapping this up, what does this all mean for you, our listener? You should now have a much more comprehensive understanding of this rapidly evolving generative AI landscape as you continue to encounter and interact with AI, whether it's in your daily life or at work. Remember this.
Yeah.
The true magic here, perhaps, isn't just in the AI's ability to create amazing things, but in how thoughtfully, how ethically, how responsibly we guide its creations. The capabilities are accelerating at an almost unbelievable rate, offering new possibilities practically every day.
It's moving so fast.
It really is. But those core principles, understanding the tech, guiding it effectively through prompting and grounding, and insisting on responsible application, those will always be your most powerful tools. We are honestly only just beginning to scratch the surface of what this technology implies for our future.
Well said. And with that, we really encourage you to keep exploring, keep asking those tough questions, and actively participate in shaping the future of AI responsibly.
Thanks so much for diving deep with us today. Until next time, stay curious.